Homework 7. It says, describe in terms of electron transfer how calcium reacts with fluorine to form calcium fluoride. Okay, like all homeworks, I'm not going to do this one. I'll do how lithium, which has an atomic number of 3, reacts with oxygen, an atomic number of 8. It says, your description should include the charges on the ions formed. Now remember, in chemistry, a description can include a diagram, and in this case I'm just going to do a diagram, a fully labelled diagram that should describe it. You're going to do a diagram, but with a little bit of an explanation as well. So lithium 3, dot for the nucleus, 2 electrons on the first shell, 1 electron on the second shell. So lithium here is going to want to lose 1 electron or gain 7, it goes with a lesser number. Oxygen next, dot for the nucleus, 2 electrons on the first shell, 8 in total, so 6 on the second. 3, 4, 5, 6, 7 and 8, that's 6 on the second shell, 8 in total. So the lithium here is going to lose this electron towards the oxygen, so we start with an arrow that starts the electron and finishes at the gap, and we're going to label that arrow E minus transfer. So this lithium's happy, and this oxygen now has got 1, 2, 3, 4, 5, 6, and this one, 7 electrons. This oxygen is still not happy, so we cannot leave it here. Now, we can't take any more electrons from this lithium, so we have to draw something else. So we've got a choice. We can either draw another lithium or we can draw another oxygen. And what we need to ask ourselves is what needs to happen here? Well, this oxygen needs 1 more electron, so we've got to have another electron coming towards this oxygen. So what's giving electrons away? Is oxygen giving electrons away? Answer no. Lithium is giving electrons away, so we need to draw another lithium. So dot for the nucleus, 2 electrons on the first shell, and 1 electron on the second shell. Now that electron is going to go from the lithium to the oxygen, so we start with an arrow that starts the electron and finishes at the gap. We're going to label that E minus transfer. Now I love labelling these arrows E minus transfer because it shows which way the minus, the negative, is heading. The negative is heading towards this oxygen, the negative is heading towards this oxygen. So this oxygen is going to end up negatively charged. It's going to end up not 1 negatively charged, but 2 negative charged. It's going to be O2 minus. That's the charge on the oxide ion. If that's negatively charged, this is going to be positively charged. That's going to be Li plus, and that's going to be Li plus. Okay, it's not Li2 plus, because we've got 2 lithiums, and both with a single positive charge. So the formula of this compound is going to be Li2O. So with this table down here now, again, I'm not going to fill it in for magnesium and chlorine. You're going to do that, but I'll tell you what, I'll do it for lithium and oxygen. So let's put another line there for lithium, and another line there for oxygen. Okay, and let's hope that helps you able to do it. First off, symbol for lithium is Li, symbol for oxygen is O. Now, lithium, when it forms the ion, we saw up here, it lost an electron, so that was positive, Li positive. Metals are always positively charged. Oxygen now, oxygen is a non-metal, and we see here that oxygen is gaining 2 electrons. That's going to be O2 minus. That's going to be negatively charged. Metals are always negatively charged. Right, so the number of electrons in lithium atom. Well, to find that out, we go to the periodic table. There is lithium, it's got an atomic number of 3, and while we're on it, there's oxygen, it's got an atomic number of 8. So that tells us how many electrons in oxygen and how many electrons in lithium. 3 and 8. 3 and 8. Now, lithium, as we saw here, lost an electron to become positively charged. So the number of electrons in lithium ion is going to be 2, and we saw oxygen gains 1, gains 2, so the number of electrons to become 2 negatively charged is 10. You fill that in now for the others. Next question. Draw a diagram to show the apparatus that could be used to test the electrical conductivity of sodium chloride solution. Well, that's salt water. Sodium chloride solution is salt water. So we're going to need a beaker, aren't we? We're going to need a beaker, so you can draw a beaker out. Then we're going to need to put the salt water in there, salt water. And then we need to see if it conducts electricity. So maybe wire some sort of bulb into the circuit. Okay, and you could put something in there and 2 electrodes in there, and obviously you're going to need to finish that off now with a complete circuit with a power supply. You may put an ammeter in if you want to see exactly how much current is flowing, You know, we can see if it conducts electricity. I suppose if the lights are on, the ammeter comes on. Finish that circuit now for me. The apparatus was then used to test the conductivity of solid sodium chloride and sodium chloride solution. The results are in the following table. Explain these results by referring to the structure of sodium chloride. Okay, so solid sodium chloride does not conduct electricity, whereas sodium chloride solution does conduct electricity. Now, to answer this, and one of the most important things is that you know what a current of electricity is. A current of electricity. Okay, so electricity will flow if there is a flow of charged particles. A current of electricity is a flow of charged particles. So if a substance can let charged particles move, then it will conduct a flow of charged particles. Now, in most cases, the flow of charged particles is electrons. Okay? Or, in this case, what we're interested in is ions. Now, ions are charged atoms. Okay? Now, go back to this diagram that we did a moment ago. These are all the electrons in lithium oxide. This is an ionic compound. Now, you can see every electron is used in bonding. Okay, so there are no spare electrons here. No spare electrons. So let's just make that point before we go any further. In ionic compounds, there are no free electrons. So, now in metals, there are delocalized electrons. That's why they conduct electricity. But in ionic compounds, there are no free electrons. They're all used in bonding. That's important for understanding, but it's not needed to answer this question. Okay, what we're interested in this question is whether the ions can move. Okay, now when it's a solid, there's no conductivity, but when it's a solution, there is conductivity. Just remind yourselves of what the ionic lattice looks like. Okay, so for example, this lithium here may have given its electron to that oxygen there. Okay, and that may be that lithium, and that might be that oxygen. Okay, but this lithium here may have given its electron to that oxygen there. Okay, that's still positive charge, that's still negative charge. Well, that positive is still going to attract that negative, even though they didn't enter into an arrangement with electrons. So what we end up with is this giant ionic lattice, where all the positives attract all the negatives, and this ends up, in some cases, being a cube-shaped. Okay, you end up with these giant crystals, three-dimensional, where every positive attracts every negative, and when we end up with very strong forces of attraction. Now, in this case, these ions cannot move. These ions cannot move. So should it therefore be a surprise that solid sodium chloride does not conduct? Because when it's a solid, those ions are held in the ionic lattice, and there's no free electrons, so it won't conduct. But when we dissolve it, or melt it, those ions can move, because the particles in a liquid can move. And if charged particles can move, we have a current of electricity. It conducts electricity. Okay? Now, I've given you an explanation, but I haven't given you the writing. You need to write that in your own words. Last bit, potassium is made of two naturally occurring isotopes. Potassium 39, 93%, of potassium 41, 7%. Calculate the relative atomic mass of potassium. Right, last two homeworks, I've worked through an example on this twice. I'm not going to work through the whole example. Go watch the video of the last homework or the one before. What I will give you, okay, is this formula. Now, if you don't learn this formula, you are stuffed. There's no way you can do that. So you do need to learn that. Okay, the 39 is the mass number. That's a percentage of that isotope. So you should be able to come up with an answer. Good luck.